Now we're just looking at simple pendulums with the period being 2 pi times the square root of L over G. If we're trying to shorten the length of the period, we can only change the length of the period or gravity. So we don't want to increase the length of the string because that'll make the period longer and the mass doesn't matter. So decreasing the length of the string will be our method to do that. Draw a free body diagram for the bob at point B. At point B, it's at the equilibrium. Gravity's acting on it and pulling it downward, and the tension of the string is pulling upward on it. Because there's still those forces acting on it, we still have to draw them in our free body diagram. What is the horizontal net force acting on the bob at point B? What is the vertical net force? So the net force in the X, which would be the horizontal net force, would be 0. There are no forces acting on it at that moment in time. The net force in the Y, the vertical net forces, the net force is also 0 because force of tension and the force of gravity are balanced at that point. Draw a free body diagram for the bob at point C. In what direction is the net force acting? Well, as the bob moves to the right, it's moving away from its equilibrium. If it's moving to the right, the net force is going to be to the left because that's the restoring force trying to bring us back to equilibrium. In this case, if we look at the diagram, we can see that the tension is actually going up and to the left, and of course force of gravity is still going down. That has not changed, nor will it ever, so let's not make that mistake anymore. What direction is that net force pointing? Is to the left. We know the restoring force is to the left. That's towards the equilibrium. That's the direction of the net force, the direction of the acceleration. At point C, the bob has tangential acceleration. What is causing this acceleration? Explain. Well, in a pendulum near Earth, the restoring force comes from a component of gravity or all of gravity, depending on which direction you're moving. Of course, when you're at equilibrium, you're moving horizontally, gravity's down. That's why we say there's no restoring force. While gravity is still acting on the system, it's not causing it to accelerate to the equilibrium any longer. If you're moving vertically, let's say at the 3 o'clock position or the 9 o'clock position on a clock, you would be moving parallel to gravity, and so you'd have the full force of gravity. So as you go from vertical to parallel, you're increasing or you're decreasing your component of gravity. And if you're going from the 6 o'clock position where you're moving horizontally, and as you go more and more parallel to gravity, you're increasing your component of gravity acting on you. What I've gotten written is the component of gravity which is not balanced to tension is what's causing this. As the bob oscillates, what happens to the direction of the force of gravity? What happens to the direction of the force of tension? Does gravity ever change? Ask yourself that. Grab your cell phone, hold it out next to you, let go of it. See if it ever does anything besides go straight down. Gravity's always down. Tension will always point up towards the center of the circle that the pendulum bob is oscillating. You know, the pendulum bob is sort of making a semicircle. The tension in the cable or the rope or whatever it is going to be your, if you remember centripetal force, it's going to point right towards the center of that circle. Of course, where the center of the circle is relative to the bob is changing as it's moving in circular motion. It could be straight up to the right, up to the left. So the force of tension is continually changing. What's not changing is the force of gravity. And as the pendulum bob changes its direction, its association to directly down, whether parallel or perpendicular, will indicate how much of that gravity is acting on the system. The period of a pendulum is 5 seconds. What's the frequency? Frequency is the inverse of period, so 1 over 5, or 0.2. What does it mean when we say a pendulum has a period of 5 seconds? What do those 5 seconds represent? A period is the time that it takes to complete one oscillation. If you're at the far left, it's how long it takes to go to the far right and all the way back. If you're at equilibrium moving to the right, you have to move to the right, change directions, go all the way back to the left, and then come back to the right and return to the equilibrium at the same direction of the initial motion, to the right. But we're talking about completing one full oscillation, one full range of the entire motion. If the frequency of a pendulum is 0.6 hertz, what is the period? Well, we know the frequency and the period are inverses of each other. So that means the period would be 1 over 0.6, but let's not make fractions with decimals in them. So we should get our calculator and say, or type in 1 divided by 0.6. And we would get 1.67 seconds as the time for how long it takes to complete one full oscillation. What does it mean when we say a pendulum has a frequency of 0.6 hertz? What does 0.6 hertz represent? Frequency is how many oscillations can you complete in a single second. This means that in 1 second, this pendulum completes 0.6 of an oscillation. So 60% of its oscillation is completed every second. Now we have a position graph, position over time, and we know the slope is velocity. And it's asking us to draw the equilibrium. The equilibrium is going to split the amplitudes from each other. So it'll go right down the middle where you'll have an equal crest above as you do trough below. I'm going to go ahead and put the scale on. So it started at -4 to -2, 0, +2 to 4. We've drawn the equilibrium through the bottom. Anywhere where the slope is 0, let's go ahead and mark those as velocity equals 0. And as it crosses the equilibrium, the tangential acceleration will be 0 because your restoring force is 0. What is the amplitude and period of the pendulum? Well, if our equilibrium is going through the origin at 0, the amplitude is going to be 4. It goes both above 4 and below 4, so 4 meters. What is the period of the pendulum? I'm kind of drawing the one period all the way through where you go through a complete cycle. It looks like it finishes right around 6.25 seconds. Circle either true or false for the next 4 questions. At point A, the velocity is 0. We've already marked that on our graph, so that's true. At point B, the maximum amount of tangential acceleration. At point B, tangential acceleration is 0, so that one's false. Increasing gravity acting on the pendulum would not change this graph. Well, the period for this system is going to be 2 times the square root of L over G. So gravity's acting, so that's going to be false. And tension and gravity are the only 2 forces acting.